Hi everyone, this demo illustrates the main features of Inventio. Inventio is a metallurgical accounting solution that performs automatic extraction of data from plant databases to aggregate and then balance them by means of data reconciliation. We have presented the main principles of data reconciliation in another video about Bilco, which is another solution that we propose. And if you are interested in seeing this other video, you can find the link just below. For the sake of brevity, this demo deals with a very simple case, but much more complicated flowsheets can be handled with Inventio.
We have a simple phase model which deals with solids, and we are also following just two metals, copper and iron. But it's important for you to know that Inventio is able to deal with a very complex phase model, so we could deal also with a liquid phase. We could deal with moisture content. We could have more than two metals. The metals could be present both in the liquids and in solids. They could move from one phase to another. So this is the flow sheet that we will be dealing on in this demo. I won't present you all of that, but it's just for you to see more or less how Inventio works. So Inventio has a stream, considers a flow sheet of streams and nodes. So streams are considering a lot of data, for example, dealing about mass, about moisture, about metal contents. And this information can be, most of the time, will be extracted from the databases of the plant. But in case we are missing 1 or 2 points of measurements, we also have some filters that are able to initialize variables that we are not measuring, especially this can be very useful, especially when we are dealing with stocks for both the stock quantity and also for the quality, the contents that are contained in the stock. So here we are dealing in this very simple example with two streams coming from two different mines. So in this case, we are considering that we have both the truck weighing and we are also sampling these trucks. In Inventio, we will just have some filters that extract and aggregate the single masses of the trucks and the single contents, the single analysis day by day, and it will be aggregated together with the masses to have, for example, a weighted average for the content. In the primary crusher, so we will also consider for the mass balance reconciliation a conservation of total dry mass and all the metals contained in it. For the crushed ore, we are still dealing with a material that is both weighed and sampled. So Inventio filter will extract and aggregate all this information. And in the stocks, so here we have another example of a situation that we can encounter. We have only the input, the crushed ore going into the stock, and we know which is the quantity of the rehandling, but we are not measuring the inventory, the closing stock, the quantity, and we are not sampling neither the stockpile. So Inventio in this case will initialize with a calculation thanks to a stock model the quantity of the closing stock and also the content of the closing stock. In this case, we are using a FIFO, forced in, forced out stock model, but we have also a perfect mixer model and also a LIFO model, last in, first out. So then more or less the rest of the flow sheet goes in the same way. So sometimes we have some information which can be directly extracted from the database, and sometimes we will be using some filters from Inventio to initialize the contents and the quantities of the streams that are not sampled or weight. So more or less in this case, we are going from the mine to the final copper cathodes. So in Inventio, I will show you how we can deal with such a flow sheet, we can identify in Inventio different main steps. First of all, when we have a reconciliation model, we generate a basis data set. In this operation, in this step, we have the data extraction from the plant databases. So the filters of Inventio aggregate the raw data that have been extracted. So we have a calculation of the sums or mean or weight averages for the contents, moistures, also some filters will initialize unavailable variables when it is necessary. So a second step, once the basis data has been generated, we examine, we check the data that has been the dataset that has been generated before the reconciliation, and for that, Inventio has some diagnostic tools. For example, we can study the node balance before the data reconciliation, so we can see which are the imbalances before. Also, Inventio has a set of color codes that warn us when something potentially wrong is happening. So, if, for example, we have a filter initializing a variable that has calculated a negative content or quantity because the starting data is not very good, so this will be flagged, and we will be able to check and see what's happening. And also during all this data generation, the extraction and the aggregation, we have traceability. So everything is tracked. The basis data set that has been generated is stored in an Inventio database. So we are just extracting data from the plant databases, not changing. We are never changing the plant databases. We are just reading information from it. We are aggregating it, and we write it on an Inventio separated database, which will be storing all the data reconciliation process, including the generation of the basis data set. So I will show you this traceability of the generation, and also when it's necessary. For example, if the data, we do not agree with data that have been extracted from the database because maybe a flow meter was capturing data, but we know there was a problem that month, and we would like to change the final value of the variable. We can edit it manually, but for this we must be careful, of course, during this kind of operations. So we have in Inventio the possibility to trace with comments to justify such adjustments, and we will also be tracking the name of the person doing this change, and this person will be able to write a comment to justify why he has changed this value. So finally, once we agree with the starting raw data, the starting basis data, we will reconcile quantities and qualities along with the constraints, so the conservation laws that can change, can be different from node to node, and the associated errors that are associated to each variable. And then also we can export the results. That's all for the introduction, so we can go directly on the Inventio screen. So as you can see, the interface has 4 main sections. One section, administration, where we define groups of users, so people who can access and the rights that they have inside Inventio. So sometimes we will have people that can only configure and model and generate metal accounting, but some people may be able just to perform the metal accounting without modifying the reconciliation model. Also, we can have people that can produce a metal accounting report, but it's someone else that can validate the work that they have done. So all these things are defined here in this section. And also another important thing is that Inventio can manage the access through Active Directory. So depending if one person is defined in the database of Inventio, he will have access and it will be identified through Active Directory. The configuration section is very technical. Normally we are not modifying it. The modeler section is the section where we are building the reconciliation model. So we are defining the filters, we are defining the conservation laws that will have to be satisfied during the reconciliation. And finally, the metal accounting is the part that we will see mainly today. It's the part that we use to perform the actual balance. So in this case, I'm opening the model, the case that I just showed you, and I will generate a basis data set. So that's how it works. Mainly, I just select to generate it, and now Inventio is extracting and aggregating the variables. It is calculating the variables that are based their calculation on other ones. So this operation can take more or less time depending on how many variables we have, depending on the size of the flowsheet that we are dealing with. And so we have a generation report telling us how many passes it has done to get to the final initialization of all variables. So here we have the data set that has been generated. As you can see, we have the name of the stream, and we have the mass, the copper, and the iron content. But as I was saying, we could have much more metal contents. We could have also moistures, and the unities also are editable. So, for example, for copper and iron, we are dealing with percents, but we could also work in grams per tons, etc. Every variable that we have here is associated to an error, to a corresponding error that will be taken into account during the data reconciliation. And if I see that one particular value is strange, maybe too high or maybe too low, I can access a data generation report. So here I see the filter, what Inventio has done to initialize to get to this final value that is shown. And so I see the query that extracted it. So we will have the tag, we will have the time of research for which we are querying the database. So we have the entire set of single masses that have been extracted. So we have their corresponding timestamp and the corresponding mass. And Inventio, the Inventio filter in this case is just adding all of this data to have a final value that is shown. It is for us mainly because of the traceability. We try as much as we can during the implementation to get the really raw data, the data that are as, let's say, as original as possible, because that's how we can trace really the information from the start to the end. And also we can see if there was maybe a problem in one particular day during one particular shift. For example, here in this list we could see that one of the values is abnormally big. For example, we can have during one shift 1,300, and so we are able to see it when we have a list. But if we are extracting already aggregated data, we do not have such information, and so of course the traceability and also the checking can be compromised, at least inside the Inventio. And also, for example, I will show you also for a copper content calculation, we have more or less the same thing. So we are extracting the contents corresponding to every shift, and these contents are associated to the weights that I previously showed you. So we are performing a weighted average of the copper content, and so we are always able to really check what Inventio has done. For example, the ending inventories, I showed you we were back calculating it. For example, the ending inventory of the blending stock, we are taking into account the masses of the beginning inventory, the opening stock, the streams that feed the node, and the streams that are being reclaimed from the stock. So a general force balance is initializing the quantity of the closing stock. And also, for example, we have the filter calculating stock content. For example, in this case, it is calculating the copper content based on the information of the opening stock, its quantity and its starting content, and as the input streams with their corresponding contents are being added to the pre-existing stock, the filter calculates with the time. It calculates the actual content, and it will associate it to the output stream, and also it will be able to calculate the content of the closing stock. So you see also, for example, here we have a red value which has been flagged, and that's why it is negative. So if I want to know why it is, I can see it is calculated using a filter, using a force balance, and actually due to the incoherencies or maybe problems on there can be problems in input of the plant basis, or just measurement errors. We are having not enough input, and so the result is a negative value, and so I'm able to see why. Now I could, for example, I could go and check the generation of stream crashed one or rehandling one, and see if there is not something wrong there, and so fix the problem in the plant databases and regenerate my data set. So this is one diagnostic tool, but also I can check which are the node imbalances before data reconciliation, and I must care if some of these imbalances are too high because it means that maybe there is something wrong in the input data. I always have to check here if there is not something that could prevent the system from reconciling. And for example, here we have the imbalances in the absolute value, so we expressed in kilotons, and most importantly for the reconciliation, also the relative value. So for example, in the primary crusher, we see that we have almost 8% of imbalance, too much input. If I think it's too high, or normally I don't have such imbalance before reconciliation. Again, I have an imbalance calculation. I can see which are the streams that are involved in this calculation of which are considered for this constraint, and again I can go and check their generation and maybe find some errors. So all these imbalances are the imbalances that are constraints for the reconciliation, and after the balance they will be totally balanced, so we will not have deviations after the reconciliation. So all of these screens can be exported in Excel, and so they can be shared, for example, in between people working on the balance. So now I will have to edit my data set because we have a negative value. So to do that, I will adjust this data set. This operation creates a second data set, so I'm not overwriting the first one, and this helps in having a good traceability. So now it has closed the basic data set, and it has opened the adjusted data set. And for example, here we are dealing with a stock. Maybe this filter is a forced balance, but maybe in the plant we see that actually this stock has been depleted temporarily. So in this case we are considering that we should put it at 0. So I will edit it, and when I put 0, actually I'm prompted to justify this change, and I cannot change actually the timestamp and my name, the name of the author of this change. So I will stock depletion, and also I will also put the associated error to 0. And what we can see also is that after such editing, Inventio flags this value with switching to red the edit button. So if someone else wants to see why, what happened, which was the starting value, and who made the change, he can actually do that. So well, for now, if you agree with the imbalances that we have here, the only thing that we have to do now is to balance the data set. So this operation again generates another data set in the Inventio database, and such, so we have a very good traceability of what happens. And here we have a screen in which we have value 1. In this column we have the reconciled data, And in value 2 we have the starting data, and so we can see also which was the deviation in absolute values, in the partial with the deviation in percentages, but also on the kilotons of metals. So for example, we have here for the copper, we passed from 0.35 to 0. The opposite. We passed from 0.29 to 0.35 kilotons of copper going in. And if we go and check also the nodes imbalances after the data reconciliation, as you can see, they are totally satisfied thanks to the reconciliation of all the values. So we also have a status of the data set. So we have an ID, we have an ID number. We have a name that we can also change, but most importantly, we have also the parent name. So I can see that this balanced data is referring to the adjusted data set. So I know this reconciliation is starting from that information, and also I have a status. And once the person that does performs the metal balance thinks he has done the best he could, he can validate this data set. This will lock the changes to the balanced data set, so no change anymore. Any change won't be possible anymore. And also it will lock the parent data set, the adjusted data 0, so we cannot perform any modifications on it. And if there is another person, a supervisor, that has to check if the validated data set is okay and the results are satisfying, he can just check it. If it doesn't agree, it can invalidate the validated data set.
All datasets are stored in the Inventio database, and the values of each variable are retrievable. There is, for example, the possibility to export bases, adjusted and reconciled data in Excel spreadsheets just by entering the dataset ID. These custom reports can have the format that is more convenient for you. So there is a lot of flexibility for them. This video showed the main features of Inventio, but many other functionalities are present to handle specific cases. So don't hesitate to contact us for more information and also for custom demonstrations linked to your case. Thank you.